Okay, it is, well, for you, it's Thursday morning. For me, it's still Wednesday night about 8:35. So I'm going to do the notes for section 4.3, polynomial division and the remainder theorem. Now, polynomial division we've already talked about a little bit, but I do want to go through a couple more examples with that. Our objectives for today, one would be to divide polynomials. So one of the things you're going to need to be able to do is to continue to do polynomial long division to determine quotients and remainders when one polynomial is divided by another. The second thing that we are going to do is we are going to use a theorem called the remainder theorem, as well as the quotient remainder theorem, or the QR theorem, to describe characteristics of given polynomials. Now, as a warm-up activity, we are going to use polynomial long division to find the quotient and the remainder when 2x cubed minus 11x squared plus 4x minus 12 is divided by x plus 5. So I'm going to give you about, we'll say, a 1 minute head start to go ahead and start getting that problem down and get going. And as you're doing that, I'll at least get our setup here. Now again, the purpose of me giving you some time here is because we've already done polynomial long division. We did it a little bit yesterday and the day before. You had a small one to do on the quiz, and actually the quiz probably was a little bit similar to this. But our goal here in kind of walking through, what you're going to do is step by step determining how the polynomial x plus 5 will go into 2x cubed minus 11x squared plus 4x minus 12. The first thing and the only thing that you need to focus on is the first term of your divisor, which in this case is x, and the first term that you're dividing into, which is 2x cubed. And you need to answer the question, what does x need to get multiplied with to get 2x cubed? And the answer to that is 2x squared. Now I put these squares over the squares. Try to keep everything lined up. Once I have that, I need to take 2x squared and multiply it times x as well as 5. So 2x squared times x is 2x cubed. 2x squared times 5 is plus 10x squared. And so I multiply 2x squared times both of these terms. And my phone's ringing, of course. Okay, 2x squared times both of these terms, and then I write them down. Now, once that's written, I need to perform a subtraction. The 2x cubed and 2x cubed should cancel out. It's the whole purpose of why we chose 2x squared. Then here, just be careful. The temptation would be to rush and go negative 11, positive 10. I'm going to put a negative 1. But here it's minus 11 minus a positive 10. Remember, I have a minus here. So I am subtracting another 10. So this is actually negative 21x squared plus 4x. And then I still bring down the minus 12 as well. So I have negative 21x squared plus 4x minus 12. Then I'm going to look and ask myself, what do I need to multiply x by to get negative 21x squared? And the answer is negative 21x. So negative 21x times x is negative 21x squared. Negative 21 times a positive 5 is a negative 105x. And then I'm going to perform my subtraction again. Negative 21x squared and negative 21x squared will cancel out. 4 minus a negative 105 is 109. Okay, 4 minus a negative 105 is 109, and so I get 109x minus 12. Now, unfortunately, these numbers are getting big, so the last number in my quotient is going to be plus 109. Now, multiplying 109 times x is 109x. And then, using our handy-duty calculator over here, maybe, 109 times 5 is 545. So I have plus 545. And I'm going to do my final subtraction. 109x minus 109x will cancel out. Negative 12 minus 545. Negative 12 minus 545, playing it safe, is negative 557. Now at that point, because my divisor was a degree 1 polynomial, I know I am done once I reach a degree 0 polynomial. And we are done. Okay? So here, the quotient would be, the quotient would be 2x squared minus 21x plus 109. The remainder is negative 557. Oh boy. Okay, we have one more to do. 6x to the 6 minus 20x to the 5th minus 7x to the 4th plus 9x cubed minus x squared minus 2x plus 7. You know, when I made this up, it was earlier in the day, but we need to do it. So we're going to write it out. 6x to the 6 minus 20x to the 5th minus 7x to the 4th plus 9x cubed minus x squared minus 2x plus 7. Now, nice thing here is, if you can do this problem, you can do anything, okay? So, I'm going to start and go by baby steps. The first thing I need to look at, first term, 3x squared, first term, 6x to the 6. And I have to ask myself, what do I multiply 3 by to get 6? And the answer is 2. And what does x squared need to multiply with to get x to the 6? And it's x to the 4th. So I have 2x to the 4th. 2x to the 4th times 3x squared gives me 6x to the 6. So I get 6x to the 6. And then 2x to the 4th times 2x is plus 4x to the 5th. Okay? And then I'm going to subtract. The 6x to the 6 will cancel out. Negative 20 minus 4 is negative 24 x to the 5th. Now here, to save time, I'm not going to write the whole polynomial every single time, but I am going to bring down the next number, which here would be minus 7x to the 4th. Okay? So, we get to the next one. 3x squared, negative 24x to the 5th. 3 is going to need to multiply with a negative 8 to get negative 24, and x squared, to get to the x to the 5th, I'm going to need an x cubed. So it is negative 8x cubed. Now negative 8x cubed has to multiply with both. So I'm going to get negative 24x to the 5th, and then minus 16x to the 4th. Almost halfway there. So now when we subtract, negative 24x to the 5ths will cancel out. Negative 7 minus a negative 16 is positive 9x to the 4th. And then I'm going to bring down the plus 9x cubed. 3x squared goes into 9x to the 4th is going to be a 3x squared. 3x squared times 3x squared would give me the 9. X squared gives me the x to the fourth. So I get 9x to the fourth. Then 3x squared times 2x is plus 6x cubed. Okay? Subtract 9x to the fourth will drop out, and then 9 minus 6 gives me 3x cubed, and I'm going to just bring down the minus x squared. And I'm going to take a break there just for a second so you can get caught up. Okay? This is a slow process. On the bright side, I'm not going to ask you to do too many of these, but when you are doing them, please pay attention to detail. So I have 3x cubed left minus x squared, and I still have a minus 2x and a plus 7. Now again, remember, the nice thing is I keep going until my degree gets less than 2. So right now my degree is a cubic, so I only have a couple more of these that I need to do. So I have 3x squared, I need 3x cubed. So I ask myself, what does 3x squared need to multiply with to get 3x cubed? And the answer is just x. So x times 3x squared is 3x cubed. X times 2x is plus 2x squared. Subtracting the 3x cubes will drop out. Minus 1x squared minus another 2x squared is negative 3x squared. And I still have minus 2x, and just for the heck of it, I'm going to put it plus 7. I'm going to start scrolling down a little bit. This is my last one, almost done. The degree in my divisor is 2. My degree down here at the 3x squared is also a 2. So this is my last one. So what do I need to multiply positive 3x squared by over here? To get negative 3x squared, a negative 1. Negative 1 times 3x squared is negative 3x squared. Negative 1 times positive 2x is minus 2x. Now when I subtract, the negative 3x squareds drop out, but also the negative 2x's drop out. And bringing down, I just have 7 left. So what I get here is that my quotient would be 2x to the fourth minus 8x cubed plus 3x squared plus x minus 1, and my remainder is just 7. Okay? Polynomial long division at its finest. Okay? Now some of you sitting in here may recall something called synthetic division. We're not going to be touching upon it here, but you can't do synthetic division unless you have a linear divisor, and 3x squared plus 2x is not linear. Okay, so now we move on to some other things. So, ask you to read through this. It says, when any polynomial p of x is divided by a polynomial of form x minus c, the remainder is always a constant. Why? Okay, and I'll ask you to think about that for a second. And it all deals with degrees. If I look, if I'm dividing by x minus c, my divisor is a degree 1 polynomial, because the largest exponent is 1. Therefore, the remainder has to be a degree less than 1. Well, that means degree 0. And a degree 0 is just a constant because there are no variables. So if I am dividing by a linear constant or linear divisor, my remainder has to be a constant. Okay? So then we get to the remainder theorem. I ask you, you write this into your notes. The remainder theorem is very powerful. What it says is, if you have any polynomial of degree n greater than or equal to 1, which pretty much is going to be anything that we're dealing with, if it's divided by x minus c, the remainder is always just going to be p of c. This allows us to find a remainder without, okay, W/O, without going through long division. Previous couple problems, we had to do polynomial long division to get the quotient and the remainder. But let's say I'm not interested in what the quotient is. I just want to know what the remainder is. In particular, where we're heading, whether or not something's a factor. If the remainder is 0, then I know that I have a factor. If there's a remainder not 0, then I know it's not a factor. So the remainder theorem simply will allow us to determine what the remainder is without having to do long division. So this is how it's going to look, okay? I'm kind of do this. It says find the remainder when 5x cubed minus 3x squared plus 7x minus 4 is divided by x minus 1. If it's divided by x minus 1, remember my goal is x minus c. So if I see minus, whatever comes after the minus is my c value. So here, if I see x minus 1, c is equal to 1. Then what the remainder theorem says is the remainder can just be found by taking the polynomial and plugging in 1. So instead of setting up 5x cubed minus 3x squared plus 7x minus 4 divided by x minus 1 and go through the whole process of long division, I can just take my c value, which in this case is 1, and just plug 1 into my original polynomial. And if I do that, coming over here, I'm going to have 5 times 1 cubed, not that I need to do that, minus 3 times 1 squared, plus 7 times 1, minus 4, and I hit enter, and I get that the remainder is 5. So if I would have done the long division, I would end up with a remainder of 5. Now what that will allow me to conclude is, if the remainder is 5, that means x minus 1 is definitely not a factor. So let's move to the next one, x plus 3. Now the whole key to using the remainder theorem is if you select the right c value. So, because it has to be of the form x minus c, if I were to write x plus 3 as a subtraction, it would be minus negative 3. So my c value is negative 3. Plus 3 is the same as minus a negative 3. Rule of thumb is this. Your c value is going to be opposite of what you see. So if I look up here on x minus 1, what do I see? I see a negative 1, so my c is positive 1. Here, x plus 3, I see a positive 3, so my c value is negative 3. So again, if I want to find the remainder, I'm going to go 5 times negative 3 cubed minus 3 times negative 3 squared plus 7 times negative 3 minus 4. Now, be careful using your calculator. If you are taking a negative number and raising it to a power, I need to put in parentheses. So I'm going to say 5 times parentheses, negative 3 close parentheses cubed, minus 3 times parentheses, negative 3 close parentheses squared, plus 7 times negative 3 minus 4. Negative 142. So the remainder, if I were to take 5x cubed minus 3x squared plus 7x minus 4 divided by x plus 3 would be negative 142. See if you can do the next three. Okay. Go identify the C values for each of those problems and go plug them in. Now hopefully I am showing you this is the work here that I need to see. If you are using the remainder theorem, I just need you to write the polynomial with the C value where it belongs. And then feel free to use your calculator to your heart's content to get your answer. So the next one, C should equal positive 2 because it's the opposite of what I see. Or you can look at minus C, so C is 2. So I'm going to have 5 times 2 cubed minus 3 times 2 squared plus 7 times 2 minus 4. And just over here, 5 times 2 cubed. Now at some point, some of these you may be able to do in your head. Minus 3 times 2 squared, like 2 squared is 4, plus 7 times 2 minus 4, and I get 38. Okay. Next one, x plus 2. My C value would be negative 2. 5 times negative 2 cubed minus 3 times negative 2 squared plus 7 times negative 2 minus 4. And if I do that, 5 times negative 2 raise, see, parenthesis, negative 2 close parenthesis cubed minus 3 times parenthesis negative 2 squared plus 7 times negative 2 minus 4. Okay. I get negative 70. Okay. Now again, if I'm making any mistakes on this, I don't think I am, but I am. Work with me. And then the last one, x minus 4, C would be 4. 5 times 4 cubed minus 3 times 4 squared plus 7 times 4 minus 4. Okay, and this seems like it's probably going to be large, but 4 cubed minus 3 times 4 squared plus 7 times 4 minus 4, 296. Okay. And that's the remainder theorem, and hopefully that should be enough. Now I'm going to go back to the original problem. Remember the first problem we did? Going backwards to here. We ended up with a remainder of negative 557. If I would have taken here at this point and taken C equals negative 5 and plug negative 5 in here for x, let's just check. 2 times parenthesis, negative 5 close parenthesis raised to the third, minus 11 times parenthesis negative 5 close parenthesis squared, plus 4 times negative 5 minus 12, negative 557. Okay, remainder theorem allows us to go get without having to go through all of this. Now again, if I have to know the quotient as well, you're going to be out of luck at that point. You have to do long division. But if all I need is the remainder and I'm dividing by something of the form x minus c, use the remainder theorem. Okay? Remainder theorem is very powerful because it allows us to find the remainder without having to do the entire polynomial long division. Remainder theorem will only work when dividing by something that is of this form. Okay? And that, ladies and gentlemen, boys and girls, children of all ages, is section 4.3. So, without further ado, that took about 25 minutes, which means you have approximately 20 minutes or so in which to get started on the homework. which is page 241, 242, problems 1 through 16. Okay, tomorrow, obviously, if we have questions on this or you need anything further, we'll be happy to go over with it tomorrow. So you may work together for the rest of the period on the assignment, and enjoy the day. I'll see you guys tomorrow.